Hello everyone, in this video, we'll be creating this deceptively simple looking 2D space shooter game. I should warn you that you should have some very basic knowledge of programming to follow this tutorial. Before we start making this tutorial, you need to download a zip file called game package, link in the description. It contains 4 files that will help in the process of making this game. There is also another link down below that will send you to a completed Godot game file of the game that we're about to make. So if some of you viewers out there who might not have time to follow the tutorial yourself, if you rather watch rather than make it yourself, then this is an option for you down below. So anyway, let's start this tutorial now. First of all, if you haven't downloaded Godot engine, you can search up Godot download on your search engine and make sure that it is the right website. Depending on your OS, either Windows or Mac OS, you should choose the correct one for your computer. You can also choose to download Godot engine on Steam. Once you finish downloading Godot, you might have a pop-up to open asset library. You can choose to cancel that and you should see something similar to my screen. Please ignore my 2D shooter here, it's my prototype for this tutorial. Anyway, we're going to click on New Project button on the top right corner to create a new project. And then we are going to call this new project 2D Space Shooter. I'll be putting this project folder on my desktop. You can put your folder anywhere. Just make sure not to forget about where you put it. Once you've selected your folder's destination, in my case it's my desktop, it might say that you should select an empty folder. You can fix this problem by clicking on Create Folder here, so that Godot can create an empty folder for you on where you want it to be. Next, we won't be changing any other setting down here, so you can click on Create and Edit button down here right away. And there you go. You're now in your project ready to start a nice new game. But since we're making 2D game, you should go up here and click on 2D so that we see our game in 2D mode. Click on 2D node and we will rename this node to world. With that done, we will go down here on the left side again to create another folder. We're gonna call it scene. Yes, we're gonna call it scene, not world. I'll be changing my folder name later. Next, we're going to save a world node using a shortcut, which is Ctrl S for the Windows users or Command S for Mac OS users. We're going to save our world node in the folder we just made, which is our scene folder. On the screen it might say world folder, but like I said, I'll be renaming my folder back to scene later. And with that, we are done with creating our first scene. Next, we're going to add a child node to our world. That child node is character body 2D. You can search it up there. This character body 2D, we're gonna rename it to player. We're gonna add child node to our player. That child node being sprite 2D. Don't forget to always periodically save. First of all, you should click on Sprite 2D. Our Sprite 2D texture says it's empty, so we're going to open our game package folder, and then we're going to drag our player ship sprite.png into the empty texture. As you can see, the sprite is very small, so we're going to fix that by going up in our project setting on top of your screen and click on project setting. In the general section, you're gonna click on the window down in the display section, and as you can see, there's size for viewport width and viewport height. We're going to change that to 320 for the width and 180 for the height. In the stretch section, we will also change the scale to 4. We're going to click on texture and then change the default texture filter to nearest. And as you can see, our sprite is now a lot more clear The sprite texture right now, it has 2 columns and 4 rows. We can make it so that it only display one sprite at a time by going to the animation section, H frame to 2 frame, V frames to 4 frame. H frames being the column, which is like I said, 2 columns, while V frame being rows, so 4 rows. You have 4 ships that you can choose as your player. By going through the frames, you can choose many different sprites. I will be choosing the first sprite as my player, but you can choose second frame or the third frame or the fourth frames as your player as well, if you would like. Next, we're going to add another shout node to our player, which will be a collision node. The collision that we're going to choose is actually collision polygon 2D, and be careful. Once you add the collision polygon 2D, zoom into your player sprite and slowly draw out your player's hitbox. For example, like I'm drawing on the screen. You can adjust your hitbox so that it is a little more generous and more symmetrical. With that done, you have successfully created your player. Okay, I want to move my player to the middle of my scene by dragging it. But as you can see, when I drag it, it moves the collision instead of the whole player. So to fix this, I first have to click my player node here, and then press this button, which is a button that will help us not accidentally move the shout node of the player. And when you drag this ship, as you can see, I can move the whole player. Why this works is that when you move the parent of the shout node also move along with the parent node. In this case, the parent node here is the player, while the shout node is the collision and the sprite 2D. Next, I will make the player movable with our keyboard input when we play our game. To do that, I will first create another folder down here called script. Word capitalizing when naming these folders doesn't really matter, and it shouldn't really give you any problem. Next, we come back up here to click on player node and then click this button to attach a script to our player. You can save the script to our new folder we just made. I will call this script player script. Once that is done, we can go inside of the script and start writing code in order to control our player how we want. First, we're gonna delete all of this code down here and all of this up here, and what remains should only be physics process delta. Okay, starting first of all, we're gonna create a variable called max speed. We're going to create another variable called acceleration, and another variable lastly is the friction. These numbers here are arbitrary and you can change it yourself however you like, but I find that these numbers are pretty okay, so I'm using that for now. Next, we're going to create movement function, and this function is going to have delta as its parameter. And this function here will run to our player movement basically. We're going to add movement function into a physics process. This physics process function here is a function that will run basically every frame. Every frame that our game updates, this physics function will run whatever it is inside of it. And delta is the amount of time that has passed in between each frame. Next, we're going to create variable input. This variable input will be vector to 0. So this input at 0 means no input yet. We're going to check for inputs from players basically. This input from players, we're going to use input.x equal input.isActionPressed. Input press UI right. Basically, when you're pressing in the right direction, it will give us 1. In the vector 2D space in Godot engine, if you're going to the right, you gotta be going in a positive direction to go to the right. While going to the left in vector 2D space, you're going to go in the negative direction. So that's why I'm putting input.x equal input.x minus input dot is action press UI left. Next, we're going to do Y for our up and down. There's a particular thing about Godot here is that going down in the vector 2D, it's actually going in a positive direction. While going up in Godot is actually going in a negative direction. Next, we're going to use our input and then we're going to use normalize function. Normalize basically give us the direction without the values, without the length basically. Next, we're going to check if our inputs are being pressed. If input.length equals 0, this basically means that there's no input. So we're gonna do else down there, which means that there is input. If there is input, then we're going to make velocity equal velocity. Now let me explain where velocity is coming from. When you extend character body 2D, this script here will get a lot of values that inherited by extending character body 2D. One of the value being velocity. Make velocity equal velocity plus bracket input times acceleration times delta. So basically the direction of which we're going times the acceleration and times the amount of times that has passed. Next, we're going to limit our velocity so that player cannot go like infinite speed or something. You can do that by using limit length. And inside limit length, you're gonna use max speed in order to stop our velocity at a certain threshold. Next, once we are not inputting anything, our player going to slowly slow down. And to make it slowly slow down, we're going to use if velocity.length. If velocity.length more than friction times delta. So once our velocity more than like let's say 0.1, a really low number. If it's more than 0.1 and if we're not giving it any input, we will slowly slow it down. Velocity equal velocity minus friction times delta. I haven't given it direction yet, so we're gonna give it velocity dot normalized. Once we reach our friction threshold or the velocity is lower than 0.1, we can make our velocity equal vector 2 dot 0, which means our velocity will be 0. So once it reaches a really low number, it just becomes 0. So basically your player stops once it slows down enough basically. Next, we're going to add move and slide down there. So basically once you use velocity, you gotta use move and slide in order to control how our player movement works. Now let's us try and play test it, going to the top right corner and clicking on the play button. Then you'll see this pop up here. Basically we only have one scene, which is our world scene, so you can just select the current scene. And you see here it's kind of actually error. So we're gonna go back to our script and we're gonna have to fix that. Turns out I forgot to change our input into numbers, so we're gonna put int bracket for our input. Instead of the input giving us boolean, we're going to convert it into numbers. Try and play test it again, and as you can see, there's something wrong with our setting. So we're going to go to the project setting and going back down to the display and window, we're going to take off our advanced setting. We're going to change the window width override to 1280 while window height override 720. For some reason my DPI is on, so we're going to check that off. And before we play test again, I'm going to add our background. So you're gonna click on the world node and we're gonna add child, which is sprite 2D. And once you add that child, we're gonna rename that child to background. Going down into the game package, you're going to drag the background PNG into the sprite 2D that we just created. Next, we're going to go to the transform section in the sprite 2D, lower the scale to 0.2. I'm gonna do 0.26, which barely fits, which is good. I think that's good enough. And we're gonna move our background into the middle by changing the X position to 160 and changing the Y position to 90. Now, as you can see here, our background is actually obscuring our player. So to fix that, we're gonna go down into the canvas item. We're gonna click on ordering and change our Z index from 0 to -5. The lower the Z index, the more in the back you will be. Next, we're going to play test it, and this should be how it works. And as you can see, you can move around using your arrow key, but you cannot move around using your WASD. So we're going back up to our project setting, and instead of the general tab, we're going to click on input tab, and inside the input tab, we're going to click on show built-in functions. Inside of these built-in functions are the functions that Godot already gives us automatically. So we're going to change our UI left, UI right, UI up, and UI down. On UI left, you're going to click on plus button and press A, and then press OK in order to bind key A to it. Next, on UI right, you're going to click plus again. You're going to press D on your keyboard and click OK. Next, for UI up, you're going to add another key, which is W, and then click OK. UI down is gonna be the S key, and then click OK, and you should be able to play test your game. You should now be able to move around your character using WASD. And as you can see here, our character, when it's moving, it's not actually rotating toward the direction that we're moving in. So we're going to fix that. Next, we're going to make our ship rotate depending on our input. First, we go into player script, and we can minimize the movement function. Down here, we're going to make a new function called player rotate with delta as parameter. Going back up here, we will make a new constant called rotation underscore speed equals 0.08. I made the number really low because that is what works for me. Going back down inside player rotate function, we will make a variable called angle equal transform.y.angle underscore to input, which will give us the angle of our player ship relative to player input so that we know which direction to rotate in order to match the input. Next, we will go down to the physics process function, and we will add player rotation function with delta. Please ignore the print angle. I will remove that later. Now, going back here, I forgot to put minus here. Next, we will make another line here. The rotate function here makes the player rotate in either clockwise or counterclockwise, depending on the value inside the bracket. This is why we are using angle times rotation speed times delta times velocity dot length empty bracket. To explain to you a bit, we're using angle so that the rotate function will rotate the player depending on the input relative to player's transform Y, which basically just gives us the correct rotation basically. I also added velocity.length so that the player rotates faster if the player is moving fast and rotates slower if the player is moving slow. And with that done, we can playtest our game and see that our player ship rotate along our input. So wherever you input, it will basically rotate toward that direction just as it should. Next, we're going to make another function. This function will be called teleport. We'll put the teleport function inside of the physics process function, just like the others. This teleport function will teleport the player when the player go out of the border. Let's say the player go out of screen from the top, the player will then teleport to the bottom of the screen. This function is very easy to make. All you have to do is to check the position of where the player is. You can see on our screen, since the size of our height is 180, I decided to teleport the player once they go above -5 and once they go below 185. You can see here when we run our game, as you can see, it is running just as we want it to. Next, we're going to do the left and right. Same thing, since our width of the screen is 320. If the player go below -5 on the left, then the player will be teleported way to the right. And if the player go 325 to the right, then the player will be teleported way to the left. And as you can see, now that we play our game, so there we go. It is working as it should. Next, I'm going to make our ship shoot bullet. But before that, I'll click on player node so that I can put our ship at the middle top of the screen by going to transform section and changing X position to X equal 160 pixel and Y equal 50 pixel. Next, we're going to make bullet for our player to use by going up to the top of Godot and clicking the plus next to our world scene to make a new scene. This new scene will be our bullet. Go to the left side and click on other node and we will use character body 2D. Now that's done, we then add two shout nodes. The first shout node is sprite 2D and the other shout node is collision shape 2D. Now we should click on Sprite 2D node to add player sprite chip.png from game package folder down here, and we are going to drag the PNG to the texture for Sprite 2D node. After that, we're going to click on animation to make our sprite sheet into showing one frame at a time. The sprite sheet has two columns, which is H frame, and four rows, which is V frame. We can change this frame by increasing frame from 0 to whatever number we need. In this case, we want bullets, so that would be frame number 7. I want to make my bullet white square, but if you want other color, then you can choose other frame like 4, 5, or 6. I forgot to rename character body 2D node to bullet, so uh, next we click on collision shape 2D node and we are going to the right side to give our collision a shape. Right now the shape is empty, so we can click on that and then click on new rectangle shape 2D down here. The rectangle is a little too big, so I'm going to reshape it to fit our bullet, and with that our bullet scene is done for now. Going down here, I rename my world folder to scene folder so that I can use it to save this bullet scene into it. Pressing Ctrl S or Command S, we are going to save this bullet scene into our into our scene folder. Now that we finished creating our bullet scene, we're going back to world scene by clicking the world scene on the top, and then we will go back into the player script. Inside of here, we are going to make another function. This function will be called shoot underscore bullet. Very creative, I know. We're gonna add shoot bullet function into the physics process function, but this time we're also going to use if condition so that we only shoot bullets when we press space or enter. To do that, we're going to put input.is action press to be if condition, and we also need to tap our shoot bullet function. Next, we are going to create a timer so that we have a cooldown while shooting your bullet. Normally, you would use a node for a timer, but we're gonna do it the convenient way. And that is to declare a variable timer equals 0 so that we can use timer equal timer plus delta, and that is it for our timer. We're going to use timer in the if condition and also using the and symbol followed by the timer more than 1. So next up, we're going up and adding another variable. This constant will be the blueprint for our bullet, so we can call and make more bullets whenever we see fit. To make a bullet blueprint, we are going to use preload, and inside the bracket we're going to add the file path toward our bullet scene. Next, we're going back down to shoot bullet function, and we're gonna use the bullet preload we just made in order to make a single bullet every time the player shoots. After that, the newly created bullet node has to become a shout or parent of something. So I made the bullets become the shout of the world node. Another important thing to do is to make the bullets position equal our position. Then we can also make the bullet spawn at the tip of our player's ship rather than in the middle of the player using this line of code. We then also gonna make our ship have recoil when shooting bullet. We can do this by writing position equal position minus bracket velocity dot normalize times 8 or any other number, but just don't do it too much. Something of note here is that we can make this line of code shorter by changing this to timer plus equal delta, which is the same as timer equal timer plus delta. Here inside the if statement, I forgot to add a line of code to reset the timer by writing timer equals 0. I'm gonna revise some of my code here. Basically, instead of using velocity.normalize, I changed to using the player's rotation with sine and cos to get a much more accurate direction of where the player is facing. Below that, I also changed the recoil a little bit. Next, to make our bullet move, I will be going to the bullet scene by clicking the bullet scene tab above here. Then looking to the left, I will click on bullet node and attach a new script called bullet and add it to the script folder. Inside the bullet script, delete all the code except physics process function and extend character body 2D. We're gonna make the constant speed equal 300 and then variable timer equals 0. We need to know which direction our bullet's supposed to move, but the values we need are inside our player and not inside our bullet script. So I have to get player's node. We can do that by using add-on ready, which means the code behind this will be run once bullet is made, and then we write valuable player to put all the player nodes value. We can get the player nodes value using get underscore node and write in the path to get player, which is dot dot slash player. Here you need to be careful because you need to spell player node exactly how you named it. Another add-on ready valuable direction equal vector 2 signs blah 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 blah. Please just copy this down. I don't want to stay too long. Now we can make the bullet move by going down to physics process function and writing position plus equal direction times speed times delta. Since we are creating more bullet when we shoot, we also have to make the bullet despawn and disappear to make the game more optimized. We can do this by making the bullet have a duration of 3 seconds and disappear after 3 seconds are up. We can use if statement like this to count the timer and then use self.queueFree to make the bullet disappear. I'm gonna adjust the speed down to 200 and going back to player's script at the shoot bullet function, I changed the bullet.position equal position times 13. Finally, with that done, I playtest and got the result like this. If your playtest is not the same as mine, please don't worry. Some of the bugs I will be fixing in the later part, and some of the things you do might change the game a little bit, so it's not really a big deal. We are going to create Earth, which is a stationary node that you have to protect from being destroyed. To create Earth, we need to click on World node and add a shout node. The shout node is static body 2D. After adding the shout node, we're going to rename it to Earth. Next, we're going to add 2 shout node to the Earth. The first shout node is Sprite 2D, and the second one is Collision Shape 2D. After that, we should click on Sprite 2D node and go down here and take the enemy sprite.png from game package folder and drag it to the texture for Earth Sprite 2D. As you can see, the sprite sheet we just added has 1 column and 10 rows. To make the sprite to individual frames, we're gonna go to the animation section on the right side here and make the H frame or column equal 1 and V frame or rows equal 10. The first frame is already Earth, so you don't have to change the frame to any other number. On the left side, click on Earth node and then click this symbol up here with me. The button you just clicked on makes it so that you don't accidentally drag shout nodes of the Earth. Now click on Earth node, then go to the right side and click on Transform section. We're gonna make Earth be in the center by changing position X equal 160 and position Y equal 90 pixels. Next, we should make the Earth a little bigger by going down to the scale and changing X equal 2, and Y should automatically also be 2 as well. Once that is done, we're going to click on Collision Shape 2D and click on the shape empty on the right side and choose New Circle. After that, we can resize the collision hitbox so that it fits our Earth. Okay, I'm gonna test run our game, and as you can see here, it is working like I want to. Oh, but there's a mistake in the bullet code, so I'm gonna go change that real quick. So going into the bullet script, I need to change the position to velocity. Lastly, we can delete delta from velocity and also make velocity equal direction times speed. With that, I'm done and it should look like this. By the way, you can change the speed of your bullet however you want. Just don't make it too slow or too fast. In our game right now, we can only shoot the bullet at a fixed interval, but I want to be able to spam my bullet. To do that, we're going back to player script. Next, coming down here in physics process function, we will check another input that will trigger shoot bullet function. We can use if statement to check if the player has just pressed a button to shoot. If the player pressed space or enter just now, then we will reset the timer and also shoot a single bullet like this. The difference between these two if condition is that input.isActionPress will continue to shoot when you hold down your button, but down here the input.isActionJustPress will ensure that you only shoot your bullet once every time you press that button, but will not continue to shoot when you hold down your button. Okay, one last thing here, I forgot that this should be else if, not if. We use else if here because we don't want both of these if statements to be true at the same time and accidentally shoot two bullets at once. With that done, let's playtest our game again, and as you can see, we can now spam shoot the bullet as much as you want, and we can also just hold down your spacebar or enter button as well if you're just too lazy to spam. You can also see here that our bullet despawns after 3 seconds. Now that we can shoot bullets, we also need to make enemies that we can shoot. To do that, we will be making a new scene. In this new scene, we're going to click on Other Node and use Area Node and rename it to Enemy 1. We're also going to add 2 shout nodes. First shout node is Sprite 2D, and second shout node is Collision Shape 2D. After that, click on Sprite 2D and go down to the game package folder and drag enemy sprite.png into Sprite 2D. On the left, click on Animation and make column or H frame equal 1 and row or V frame equal 10. Next, I'm going to click on enemy 1 node and click on this button to group the enemy node with the child node. And then going back to the left, we are going to use frame number 2 here. You can use other frame as enemy sprite, but I like this purple stick to be our enemy the most. Next, click on collision shape 2D node and go to the left side to give our collision node a shape. I think capsule shape fits the current enemy sprite the most, so I will be using this shape and reshape the capsule to fit the enemy sprite. With that done, we finish making enemy scene and we can save it with Ctrl S or Command S. We're going to save our enemy 1 scene in our scene folder, so make sure you save it in the right folder. After that, we're going to create a new script for our enemy 1 node. Make sure again to save the script in the script folder, then click OK. Inside the script, let's delete the function ready and other unnecessary lines. After that, we're going to make constant speed, which will be the speed of our enemy moving toward Earth. And to move toward Earth, we need to get Earth's position. We can get Earth's position by getting Earth's node using getNode bracket and writing in the path to get Earth's node like this. Now, inside the physics process function, we will make the enemy position equal position.move toward bracket earth.position times speed times delta. This line of code basically make our enemy slowly moves toward the Earth's position at a constant speed of 20. Now that we're done with making enemy 1, next we have to go back to our world scene and click on world's node because we are going to add a new script to it. This new script, we're going to call it enemy spawn, and then we'll save it in scripts folder and go inside of it. As the name suggests, we will be creating new enemies periodically over time using this script. We first delete the part we don't need, change the process to physics process to stay consistent with other scripts, and make constant enemy pre equal preload bracket enemy file path. Please make sure to choose the correct path that ends with enemy.tscn. This constant will be our blueprint in order to create more enemies. Next, we should make a timer to keep track of enemy spawning intervals. We're going to periodically create enemy every 1 to 4 seconds. To do this, we're going to use ranf range bracket 1 and 4. The ranf range is a function that will give us a random number in between 1 and 4. For example, it might give us back 1.3 or 3.8 as long as it is within the range from 1 to 4. Anyway, inside the if statement, we're going to use a random variable to choose where our enemy will spawn at. This time, we will use rani range bracket 1 and 4. This will randomly give us 1, 2, 3, or 4, and they won't have decimals. Next, we will check the random number using match, which is similar to if condition, but I think it's a lot more straightforward. But before going down there, we should instantiate our enemy, or in other words, create or spawn our enemy 1 here. After that, using match random colon here, we can see if the random variable is equal to 1, and if it is equal to 1, then we can make the enemy appear from the top of the screen by making the enemy position equal vector 2d, x equal ranf range minus 10 to 330, and y equal minus 10. Going back up here, I forgot to make the new enemy we just created or just instantialize become a child node of the world node. You can just type add child enemy. And then going back down here, if our random variable is equal to 2, then we're going to make the enemy appear from the bottom using the same vector from before and changing y from minus 10 to 190. And then going down here, if our random variable is equal to 3, then we're going to make the enemy appear from the left side using vector 2d x equal minus 10 and y equal randf range from minus 10 to 190. And lastly, down here, if our random variable is equal to 4, then we're going to make the enemy appear from the right side by using vector 2d x equal 330 and y equal randf range from minus 10 to 190. Oh, sorry, going back up here again, I forgot to reset the timer back to 0. And that is it for this script. We can now play test our game to see if there are any problems. As you can see, the enemy finally spawned and moved toward Earth as it should. Now I want to go back into enemy script and make the enemy spin while moving toward Earth so that it's a little bit more menacing. We can make it using rotate function and using a random variable up here and putting it in the bracket. Also, don't forget to times delta. And I also should probably make the numbers up here a lot bigger. Let's say to, I say 6 seems okay. Yeah, 6 seems okay. Let's play test our game and okay, there you go. I think this looks good now, but you can go play with some other numbers if you would like that better. So yeah, have fun. One problem I see here is that every single enemy moves toward Earth at the same speed, and I think having some enemies be faster or slower than the others sounds a little more fun. So let's go do that. We're going to go back to enemy 1 script. We can change to random number using randf range function from let's say 10 and 35. And also change the constant to variable. Okay, I think 35 is a little bit too low, so I'm gonna change it to 50. And let's play test our game, and as you can see here, I think that should do it for the enemies. On our next agenda, we should be able to kill enemies using our bullets. To do that, we are going back to the enemy scene and click on enemy node, and then go inside enemy script. Now that we're in here, we are going to go to the top left side and click on Node tab here. Now you should see this, and you should go down here and double click on body entered. After that, this should pop up, and then you can click OK right away. This should make a new function appear down here in enemy 1 script. This function is called onBodyEntered bracket body. We can use this new function we've created to detect collision between enemy and bullet, enemy and player, and enemy and Earth. To actually detect collision, we have to go to our bullet node, player node, and also Earth node to give all these nodes a group so that Godot can detect collision on these nodes. First, let's go to the bullet scene and click on bullet node, and then go to the top left. Click on the node tab here, and click on the group here, so that we can add a group for the bullet. We are going to call this group bullet and added. Next, we're going to the world scene and click on Earth node on the left, and then we're going to give it a group as well. We're going to call this group Earth and added. Lastly, we're going to click on player node here and add player as the last group here. Now that that is done and over, we can go back to the enemy script, and inside of the enemy script, go down here inside of the body enter function. We're going to add an if statement to detect enemy collision with bullet. You can write it like this. So now if the enemy collide with the bullet, you can use self-kill free to make the enemy disappear. Next, we can copy and paste this if code 2 more times, and we can just change the group. The second one is enemy collide with player, and the last one is enemy collide with Earth. Now you can play test your game. As you can see, once the enemy collide with our bullet or Earth, or even the player, the enemies should disappear instantly like you're seeing right now. Next, we're going to make a new scene for using particle effects for when the enemy dies, and only using what we've learned so far. Just like before, we're going to click on the other node, and this time we'll use only one node, which is Sprite 2D. We'll rename this to Particle Enemy. Click on Particle node, and down here on the game package folder, we will drag the player ship sprite.png and drop it into the empty sprite texture on the left. After that, click on the animation and make H frame or column equal 2 and V frames or row equal 4, and also change the frame to number 5, which is the blue square. I'm choosing blue square because our enemy is purple, and I can go to the visibility and change the modulate so that the color become more purple like the enemy. After that, we can save the particle enemy scenes inside of the scene folder. Now we're going back to the enemy script. Inside of our enemy script, up here, we're going to create a blueprint for the particle scene we just created a second ago. Make sure to preload the correct scene. After that, inside of the onBody enter function and inside the first if statement, we will make 3 particles. We can do this by typing the instantiation 3 times and then adding 3 newly made particles to the world using the get parent and add node like this. And as you can see, it looks very messy. So we're going to go up here and make a function called particle maker and copy one line here and paste it here, and this line here and copy and then paste once again. Now we can delete this code here, and going back to the function, we can make the position of the particle equal where the position of the enemy is at, like this. And with that done, we can go back down here and write particle maker function and repeat it 3 times. But there is also a better way to do this. We can use something called for loop I in 3, which means whatever code you put inside of this for loop will be repeated 3 times. We can also use loop for more, like 6 or 10 times if you want, but I only want to do it 3 times. Copy the for loop and paste it in the last if statement down here. Now we can playtest the game, and the enemy should leave purple square after you kill them. As you see here, the purple square are there, but they're not moving or fading away. To make these particles move and fade slowly, we should go back to the particle enemy scene and click on particle enemy node, and then attach a new script to it like this. We're going inside the particle script and delete the ready function. First, we will make a constant speed equal rand f range to make the particle move at a random speed. Secondly, we will make valuable timer equals 0. Next, change the function process to function physics process. Inside the function, we will make a particle move away from Earth using move toward, but in the opposite direction, so that the particle will move away from the Earth instead of moving toward the Earth. That reminds me, I forgot to get the Earth's node up here like this. Now we can add Earth position in move toward function, and after comma, we will also add the speed times delta as well to direct how fast we want our particle to move away. Okay, after a lot of trial and error, I find that using this line of code here works best. It's basically finds the direction, which is big bracket, and then times speed times delta. But the problem is we also want the particle to slowly fade away and then disappear completely. So to do that, we're going back to particle enemy script. Now let me adjust the particle speed and add a timer so that the particle will despawn after 4 seconds. And to make the particle fade away, we need to reduce the opacity of the particle. We can do this by going to the modulate.a and slowly deleting it using random value like this. For some reason, I put the modulate inside of if when it should be outside. Anyway, I realized that I need to make a random variable outside the function. So up here we are making variable for random equal random f range bracket 0.5 and 1. Next we should fix this, and after that we can go into the if statement to make particle disappear completely after 4 seconds using self dot kill free. You don't need to add timer equals 0, by the way. I only am doing this because I'm stupid. Also, coming back up here, I'm going to change the number here and make it lower. I think it should work now. Okay, so I think I forgot something. Oh yeah, I forgot to make a random times delta down here. Now I should probably make this number a little bit more far apart. We should test out if this works now. Anyway, I got an idea to also slowly make the particle change its color the longer it's on screen. So we can do that by making another random variable, which is random2 and modulate dot b minus equal random2 times delta. Actually I think it should be dot r. Okay, to explain you what this line of code does is that it slowly deletes the red value away from particle, hence why I'm using modulate dot r instead of b. So if you want to delete color green, you can use .g. If you want to delete blue, then you can use .b. But there is still one more problem, which is the fact that all three particles from one enemy all move away in the same direction. We can fix this by again making another random variable. This time I'm going to call it random vector equal vector 2d bracket ran f range minus 3 and 3 comma ran f range bracket minus 3 and 3. After that we will go down here and type in position plus equal random vector times delta. After playtesting, I realized I need to make the random vector number a way bigger. So I made it, so I made them, well no, okay, maybe minus 30 and 30 works better. With that, I think we're done. Let's see the result of our code. I think I really like it a lot with how the particle slowly changes color and disappears and fade into the background. You can edit the script however you want, change the number here and there. Just don't accidentally cause an error. And if you do, then I hope you can fix it. So good luck with that. Okay, since the enemy has particle effects now let's give our player particle effects as well. First, we'll make a new scene. Click on the other node here and use Sprite 2D and rename the node to Particle Player. Now click on Particle Player node and then go down to the game package folder and then pick the player ship sprite.png and drag the PNG to the empty texture on the left side. On the animation, we'll do the same thing, which is hframe equal 2, vframe equal 4, and frame equal 4. After that, you should get this red square. Next, we'll go to the world scene and go inside the player script. Minimize the shoot bullet function and create another function called shoot particle. Next, we'll go up here and make a constant blueprint. You can copy and paste the first line here and change the constant to particle player pre and then put the path to particle player.tscn in preload. Going back down here inside the shoot particle function, we will make a variable to hold a new particle and create a particle using the particle player pre.instantiate. Beware of typing wrong characters, by the way. I do those mistakes quite a lot myself. After a new particle is made, we will add and then we will put the position of the particle where the player position will be at. Moving on from that, we should go back to particle player scene and click on the particle player node and then give it a new script. We will create a new script called particle player and put it into the script folder. Then we will go inside the particle player script and delete the unnecessary part and change the process function to physics process function. After that, we will go to the particle enemy script and copy everything there and come back to the particle player and paste everything where it should be. Next, we should change get node here from earth to player so that we know where the current player position is. Also, come down here to change earth to player as well. Go inside the bullet script and then copy this line of code here and then go back into the particle player script and then paste it here. Next, we will delete this line of code and then write position plus equal direction times speed times delta. Oh wait, oops, I meant to type minus, not plus. Okay. And with that, we will go back to player script here in the shoot particle function. We will make the particle spawn a little bit behind the player instead of the middle of the player. And we can do that by writing this particle dot position minus equal blah 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 blah. You can actually go to the bullet script and copy this part and go back here and paste it once again. Basically, this gives us the direction where the player is facing, and we can use that and times 12 to make it a little bit more impactful. Lastly, we will go up here and open up the movement function, and in the out section down here we will add shoot particle function like so. What we're doing here is essentially we're shooting particles when player is pressing some kind of movement like WASD. As you can see, our player particle is a little bit too far behind, so we're going to go back to player script, and inside of the shoot particle function on this line we will change 12 down to 5 so that the particle is not too far. Another problem I see here is that the particle are on top of the player when the player should instead be on top. We will go back to the world scene to fix this. Next, click on 2D and then click on player node, and then down here on the bottom right to the canvas item and click on ordering. Make the Z index to 3 so that our player sprite will not be obscured by any other sprite. Okay, so another thing that I want to change here is the color of the player's particle. To do that, we will go to the player's particle scene and then go inside the particle player script. Up here, I will copy and paste another random variable and give it some other value. Next, we'll come down here and change the particle color by giving the modulate.r minus equal random2 times delta and changing it to modulate.b minus equal random3 times delta, and there we go. We now have a jet particle on our player. Like I said before, you can play around with the numbers. Your game don't need to look exactly like mine. Okay, let's go back to our world scene up here and then click on 2D. Now back to here, we're going to create lives. And if the enemy collide with the earth, we will lose 1 life. And we only have 3 lives. So to create lives, we will go click on the world node and add a child node. This node we want is node 2D, and we will rename node 2D to lives. After that, we will add 3 child node to lives node. The first child node is sprite 2D, and we will rename it to life 1. Then we will copy the life 1 node and paste it 2 more times and paste it again to get 3 life basically. Now click on life 1 node and go down here to game package folder and pick the enemy sprite.png and then drag the png to the empty texture on the right. We will click on animation and make h frame equal 1 and make v frame equal 10. We will use frame number 8. Here is a heart, and we will go to life 1 node and we will move the life 1 node to the top left corner up here. We can enable grid and then use grids. We can line up life node 1 a lot better now. Next, we're gonna remove life 2 and life 3 node because we just need to copy life 1 node and then paste it again 2 times just like this. After that, we can move the life 3 node to the right side and then life 2 node to the middle. Make sure you have life 1 node on the left, right 2 node on the middle, and write3 node on the right. Next, we will create a script, but I won't make it attached to any node because I will be making it something called global script. Anything inside of this script can be accessed by any nodes, any scripts, and any scene basically. It is very useful. And to make it, we can just click on live nodes here, and then we will make a new script just like any other script. We will call it global, and then we will save it in script folder. You can see here that global script is attached to live node, but like I said, I don't want it to be attached to anything. So I will detach this by clicking on this here. Now that we've created global script, next we're going to click on lives node again and make a new script and call it lives. Then we will save it in the script folder. Next we want to go down here into the script folder and check out the global script. Once you have found the global script inside of the script folder, you can double click to open it. Inside of here we can delete everything and then make two variables. The first one is lives equal 3 and the second is score equals 0. Next, we will make this global script accessible to every other scripts and nodes by going up to this project and click on project setting. This time, we will go to the auto load tab and click on file symbol to find the global script inside the script folder, and then make the name global without capital G, and then you can add the script, and just like that, our two variables inside of the global script can now be accessed by any other script. Next, going inside of the live script, next we will go into the live script and delete the ready function and change the process to physics process function, and then we will make a timer and a timer plus equal delta to count the time. Next, we will use match with global.lives, which will access the global script and return the number of lives equal 3. So here, if the global lives equal 3, then all the child node of lives, which are life 1, life 2, and life 3 nodes, will set on frame number 8. If you don't know the dollar sign here, it helps me access the child node of lives, which in this case being life 1, life 2, and life 3 nodes. Next, if the global lives matches 2, then life 1 node and life 2 node will be set to frame number 8, but life 3 node will be set on frame number 9, which is a heartbreak. Next, if the global life matches 1, then only one life node will be set on frame number 8, but life 2 and life 3 node will be set on frame number 9, which means 2 heartbreaks. And lastly, if global lives matches 0, then all life 1, life 2, and life 3 will be set on frame number 9, which means you are dead. Now, we have not made it so that when enemy collides with Earth, we would lose 1 life. To fix this, we would go to enemy 1 scene and go inside the enemy 1 script. Inside of the script down at the bottom, inside of the last if statement here, we will add global.lives minus equal 1, which means if the enemy collides with Earth, we will lose 1 life. Now, let's playtest our code, and as you can see here, it works just like how I want it to. Okay, going inside of live script, we will make a def effect. By def effect, I mean when the player loses all their lives, then both the player and Earth will blow up into a lot of particles. To do this, we are going to go up here and copy this timer line and delete it and paste it back down here instead. Next, we will go back up here and make a new function called def. Go down here to run def function once. We lose all of our lives. Then we go back up here to get player node and earth node using get node function. We are getting player and earth nodes so that we know where their positions are and make the explosion of particles happen at their position once we lose all our lives. Okay, back to our def function. Once we die, we have to make the player and Earth disappear. We can do that by making them both invisible. Next, we will make a lot of particles using for loop I in 3 to triple the amount of particles. By the way, don't make this loop number too much, or I mean too high. It might make your game slow down from spawning too much particles. Up here, I forgot to make a blueprint for particle pre equal preload bracket path to particle player. After that, go back down to for loop and make the variable instantiate to make new particles. Next, we will add the new particles we just made and add it into a child node of the world node like this. Next, we then make the particle.position equal player.position and then copy and paste the for loop. We change the player.position to earth.position here. Okay, next we are going to go inside of enemy spawn script to add an if condition to only make enemies when we are still alive. To do that, we can use if bracket global lives more than 0 and then highlight everything below if condition and then press tab. Next, we're going to go to a player script, and inside of the physics process function down here, we will also do the same thing. Next, we're going to display the amount of score, which will be the total number of enemy you've killed in a single game. First, click on World node here and then add a child node. This child node is Label. Click on Label and rename it to Score. Next, click on Label node and go to the right side to put in some text in the text box. Here I put in Score colon. Next, we should drag the score text to the top right side around here. Next, we will attach a new script to the score node and we will call it score and save it in the script folder. After that, go into the score script and delete ready function and make process function to physics process function. Next, we are going to type text equal quotation, score colon, and plus string, str, well, same thing, global.score. Now, just like this, we'll be displaying the score you have, but we haven't made bullet and player's collision with enemy count as +1 to our score yet. So we have to go inside the enemy script and go down to the first and second if statement here. If bullet collide with enemy, then global.score plus equal 1. Next, we can copy this line of code and put it down here in player's collision with enemy, which will also give us more score. Actually, make sure that you don't accidentally put global score plus equal 1 inside the for loop. So just to be safe, we're gonna put it above the for loop. Now let's playtest our game. As you can see, it is working as it should. Our bullet is now killing the enemies and giving us points. First, we click on World node and then add two labels node. Drag the first one to the middle and type in press space to play again, and then rename label to play again. Next, we should also drag the second label to the middle down here and then rename it to latest score. And of course, write your last score colon inside of the text on the right. Okay, to explain what we're doing here, the play again label, we will make it flicker invisible and then visible again, while the latest score is basically a display to display the last score you got after you die. Next, I'll click on the latest score node, attach a new script, call it latest score and save it to the script folder. Inside the latest score, we will clear the ready function and make physics process function. Then we set text equal quotation your last score colon plus str global score. This script is basically done now. So we will go back and click on play again node and attach a new script, save it inside the script folder just like all the other folders. After that, go inside the script and do the same thing here, and then add timer equals 0. By the way, the next two if statement are wrong for now, but we will fix this later. But for now, we're just going along with them. We are doing we are basically doing this to make our play again node go invisible and become visible again every 2 seconds. Next, we're going back to the world scene in 2D, and we're going to make the play again node and the latest score node invisible, because it should only become visible after the player dies. So going back inside of the play again script, we will change the function to physics process and then add an if condition here to make the play again node visible again once the player dies. We then highlight the whole thing here and press tab. Next, we will go into the live script, and coming down here, we will delete the whole thing down here, and instead we will go to the top of the function and write the whole code here instead. This basically runs the timer once you die, and after you died for 2 seconds, we will stop the death particle effects, and we will also make the play again and latest score node become visible again as well. Sorry, I dumped 7 lines of code here without warning. I kind of lost some footage here, so that's basically that. Next, we should go inside the play again script to fix this because it is wrong. First, we delete that and condition, and then we replace else with if condition and delete timer 0 here as well. I suppose I am supposed to write if here, not else if. Okay, now that this is all fixed, this code basically makes play again text node invisible for 2.5 second and then become visible again after 2.5 second. I also need to fix it to make it become 1 second and then 2 inside of the second condition, and I think this is a lot better now. Last thing we need to do here is to make our game playable for as many time as we want. When you die, you can restart and play it again basically by checking for spacebar input after the player has died. And to do that, once the player press spacebar here, we will reset the global lives back to 3 and global score back to 0. And last but not least, in the final line of the code, we'll reset the whole scene so that we can play this game again. First, we'll get the tree for the scene, and we want to reset using the reload the current scene to tie them all together. So now we can replay the game again if we just press space at the end. Okay, I forgot 2 more bugs that need to be fixed. First, go inside of the score script here. We should make the score node invisible once the player dies. And the last bug to be fixed is inside of particle player script. Going down here, we will make the particle position be affected by our player's ship direction only when the player is still alive. And finally, with that done, let us play our game and see the result of our hard work. I should congratulate you if you got here this far. You've really got strong drive and tenacity to be able to listen to me spew so much. So basically, from the bottom of my heart and to sincerest gratitude, thank you. For those of you out there who wants to export this game, up here you can see there's an editor tab. There should be manage export template. You can click on that, and inside there you can download and install an export template. This will basically help you export your game. Once you download it, just click close and you can go up to the project, click on project, and you can click on export. Once you click export, this should be the screen that pops up for you. You can choose any of these OS you want your game to be on. Next, in here, you're going to add, you don't need to add everything. Icon here, you can take one of the image from game package. I got one icon that we could use. Yeah. And then we're going to give our product name and computer name because why not? With lazy koala. Yeah, and then you can straight up just export it, put it anywhere. I put it on my desktop so that it's easy to access once again. And there we go. I'm done. I hope these videos of ours help you somehow in your game development journey. Um, it is quite tough to make these videos, I must say. So I would appreciate your like, subscribe, and all of that stuff. Thank you for watching all the way through here. I saw some bugs myself after editing this video, and let's just say I'm kind of cringing right now. Anyway, rather than going to fix it myself, let's just put it as like a little spot the bug yourself, basically. If you can fix it yourself, then that's like, that's wonderful. Anyway, I just wanted to say thank you for watching our video, and I hope that our video has helped you improve your. I'm just gonna go sleep now because this this is now like giving me sleep deprivation. Anyway, bye bye.